are 40 biology likely Jamb question. Okay, let's get into it. So the number one question states, we are given a particular structure or label like this. Of course, first of all, you want to know that this is what? This is animal cell, right? Because there's plant cell and there's animal cell. Alright, so one of the things that you want to know, the major distinguishing factor is that animal cell lack what we call the cell wall, okay? The cellulose cell wall is only present in plant cell, okay? Now, this is animal cell, right? Because you can see it is not as rigid as plant cell. So if you have something like this, and you are asked, the structure labeled 5 is the dash. Where is 5? This is the structure 5, okay? Which means it's these organelles here. Now, one of the ways to note organelles is that they have special features to denote them. So when you see something like this, and you see that sausage-like structure in between, then you know that this organelle is the mitochondrion. Mitochondrion as the singular, the mitochondria as the plural. Okay, so this is the organelle denoted with this particular Roman figure here. So now one of the things that you also want to know is that mitochondria is the powerhouse. Is the powerhouse of the cell. Is the powerhouse of the cell. Okay, that's what you want to know. So the answer to this question is option C, mitochondria. Okay, that's very easy. Now, question 2. Which of the labeled parts of the cell contains ribonucleic acid? Okay, now if you look at this cell, this particular part here, which is called what? The nucleus. Okay, inside the nucleus, there's what we call a double layer nuclear membrane. This thing you are seeing here is the nuclear membrane. Okay, is the nuclear membrane. All right. Now inside this, we have this part here, which is called the chromatin material. Then here is what? Is the nucleolus. Now this nucleolus is a dark stained part in the nucleus. So when you see that dark stained part here, is the what? Is the nucleus. And it is this nucleolus that contains the ribonucleic acid, RNA. So the answer to this question, question 2, is what? Is this particular part, which is Roman figure what? Roman figure 6. So which is option C. Okay, Roman figure 6 is the answer to that question. So question 3. Which organelle is responsible for protein synthesis? Protein synthesis. Now, you want to take note of something, that when we talk about protein synthesis, the major organelle is ribosome. And don't also forget that we can have what we call the endoplasmic reticulum. Okay? Now, people don't understand this. They don't understand it. It says that they don't know that when we have, look at it. If you have something like this, okay? Now, it's different from when we have a stack of coins like this. Do you get it? Now, this they are seeing without encrusted ribosome. This is called smooth endoplasmic reticulum. That is, it is a smooth endoplasmic reticulum. Okay. Now, if it has encrusted ribosome on it, because there are two types of ribosome: the free ribosome and the bound ribosome. Okay. So when it is bounded to an endoplasmic reticulum, we call that, because of the encrusted ribosome on it, we call that one rough endoplasmic reticulum. So in two senses, we can have the rough endoplasmic reticulum be responsible for protein synthesis because of the encrusted ribosome, or ribosome in itself responsible for what? Protein synthesis. While smooth endoplasmic reticulum is responsible for what? For steroid synthesis. Okay? Steroid synthesis. Now, sometimes they call it lipid and steroid synthesis. So the answer to this question now, for instance, which are example for protein synthesis? Now, you can see that mitochondria is, of course, not that. Lysosome, not. Ribosome is the answer. Not smooth endoplasmic reticulum, because smooth is also for what? Lipid and steroid synthesis. Okay? So the answer to this question is what? Is ribosome. Alright, now question 5. The part labeled 5 is called dash. Where is the part label 5? Okay, this is 5. No, I think this should not be 5. Let me see. Question 5, the part label should be 2. The part label 2 is called dash. Now look at it. The part label 2, can you see? You see that this guy is like this. I want to take notes of something. Look at it. Sometimes you don't have to let it go inside. Just like this. Can you see? And there's no encrusted thing. So that means this guy is the smooth endoplasmic reticulum. Okay, smooth endoplasmic reticulum. So that's option D. Alright, that is so easy. Now, question 6. Dash is known as suicide bag of the cell. Now, this is a very, very important part that you must understand. Now, in terms of suicide bag, there's something called the hydrolytic enzymes. Okay, that in fact, after the whole, if someone dies, for instance, that's the last part of the cell. Sorry. That is the last part of the cell that actually dies. Okay, it is the what? It is the lysosome. So it can hydrolyze the whole cell. So that is the last part that dies eventually. So that part, that lysosome is denoted or is noted as what? As suicide. Can you see? Suicide. That is, it can cause the death of its cell. Do you understand? So suicide bag is the organ known as suicide bag is what? Is lysosome. Okay, lysosome. Very, very important. Alright. Number 7. Dash is known as control house of the cell. I mean, from the name, control house of the cell. Dash is known as the control house of the cell. What is known as control house? Of course, it's so no-brainer that the nucleus is known as what? As the control house of the cell. I think I missed a question. Okay, question 4. Sorry, I missed question 4. Question 4. Now, protoplasm comprises nucleus and dash. Protoplasm comprises nucleus and dash. Now, you must understand that the protoplasm is the living part of the cell. It's actually the living part of the cell. Okay, so it contains both the nucleus and what? Cytoplasm. Okay, just like you can see, this part is the nucleus. Why the part where other organelles are embedded is the cytoplasm. Okay, you understand? So that is why protoplasm is a combination of nucleus and cytoplasm. So the answer to this question is a combination of nucleus and cytoplasm. Alright, very easy. Now, let's go back to this. So the control house we said is the nucleus. Now, question 8. The part labeled 4 is called dash. Where is 4? Where is 4? Okay, this is 4. Yes. The part labeled 4 is the dash. Now, anytime you have a stack, something that looks like a stack of coins, look at it. Look at it. Can you see 1, 2, like a stack, 3, like that, 4. Now, this is what we denoted, or we noted as what? Golgi apparatus or Golgi body. Golgi apparatus. Or sometimes they call it Golgi body. Okay? Now it's where from the endoplasmic reticulum, like a thread. Look at this. It's where from this. Can you see? It's where from this. Can you see that? So this one is where from when you have it like a stack. Like a stack of coin. So if I that's what they denote it as, it looks like a stack of coin. So when we have a stack of coin, so the answer to this question is what? Is Golgi apparatus. Of course, you should know that this is reserved for the packaging, transport of materials. I mean, it's reserved for the packaging and transport of what? Of materials. You have to understand that mitochondria is reserved for what? Aerobic respirations. Okay, because it's the powerhouse of the cell. Okay, so respiration generally, mitochondria is reserved for that. All right, you want to understand that. Protein synthesis, we already established ribosome, we already established cytoplasm, suicide bag. And another thing I want to know is that mitochondria, another thing for mitochondria is what? Is powerhouse. Is noted as powerhouse of the cell. Okay? Powerhouse of the cell. So let me see other parts. Now, if I ask you, Roman figure 3, what is that? You can see that this is endoplasmic reticulum. and it has encrusted ribosome. Encrusted ribosome. So this one figure 3 is what? Is rough endoplasmic reticulum, which is also responsible for what? Protein synthesis. Now, this guy here is this IX here is the encrusted ribosome. So it is called the bound ribosome, or sometimes they call it what? Ribosome. You understand? Why I'm saying bound is that it is bounded to this endoplasmic reticulum. Okay. Now that is that. Then this part here, this thing that you see here is the chromatin thread. This thing you see here is the what? Is the chromatin. Is the chromatin thread. Is the chromatin thread, okay? Or what we call what? The chromatin material. Is the chromatin thread, or what we call the chromatin material. So I think yes, of course, this part, in case they label this part, is the what? Is the cell membrane. Is the cell membrane, okay? For animal cell, for plant cell, of course, you know that this is animal cell. For plant cell, let me just have that drawn. Maybe that I will explain that to this part. I will explain that to this part. So let's say you see something like this. Now, look at it. That rigidity that this guy has gives it away. Okay? So that means you should have been thinking that this guy has what we call the cell wall. So that's why the stem of plant is so turgid, it's so rigid. So that rigidity is because of the cellulose cell wall. Okay? That's why they call it a structural, you understand? A structural polymers. You understand? A structural polymers. You understand? So just like we have a storage one, like glycogen and starch. Okay, so this cell wall is a structural one, structural support. So just like that's why the rigidity. You can see that this one is somewhat flexible. Can you see? You understand? So this is rigid. That's why before you can cut down plant, it's so turgid, it's so rigid. Okay. Now you understand that for plant there is a large vacuole. This large vacuole, the cell wall of this vacuole is called what? It's called tonoplast. It's called tonoplast. The cell wall of this large vacuole is called what? It's called tonoplast. But something I want you to note is that this particular plant, it must have an organelle which is responsible for photosynthesis, and that organelle is what? Is chloroplast. This is tonoplast. This is chloroplast. So inside the chloroplast is where we have what? The chlorophyll. It's where we have what? The chlorophyll. Alright, so they can now be other organelles. I just want you to take it for something that it is not just a vacuum, it is a large vacuum. They can have other organelles. So this is what I want you to take note. 1, a rigid cell wall. Number 2, large vacuum. Number 3, chloroplast. Alright, now this large vacuum, the cell wall of that large vacuum is called tonoblast. Okay, now this guy here, this large vacuum contains cell sap. Cell sap, alright. Don't worry, in this part of this video, I'm going to explain how to recognize the stem of dicot, monocotyledons and dicotyledons and all of those things, okay? Don't worry, just follow through. So, well, that's by the way, I know that this is about day 2 of the Jamb. Jamb has started since yesterday. This is day 2 of Jamb. So, and our marathon class has ended, but there's recordings for all our classes. So in case you want to get the recordings, you can send me a DM if you are watching this on TikTok or YouTube to access the recordings, okay? Alright, so send the word marathon recordings to my DM, then you get access to all my chemistry recordings, and that you can use it to prepare for your exam. So just like I said, I hope this explains this, and yeah, these are major questions that I can ask from you under cell, under cell and structures, okay? Yes. Okay, this part I'm going to be explaining all the monocotyledon stem, the dicotyledon stem, the monocotyledon root, the dicotyledon root, all those cross-sectional, section of those things, and I will tell you how to understand that part. Okay, so that's why they're about, I'm using this section for question 9 to question 20. In fact, there are a lot of questions I'm going to be answering with this, so pay attention. Now, imagine you are doing a question like this, because this is a Jamb question. I just compress it because I want to explain this part very well, okay? Now, the first thing, you have seen diagrams like these 5 figures, right? Figure 1, figure 2, figure 3, figure 4, and figure 5. And you are asked, what are the structures, okay? Now, let's go into it. Now, if you see this particular structure, how do you know that it is a root or it is a stem? That's the first thing, right? Now, you should know that if you have a plant tree, right, you should know that there is a stem, right? There are leaves, right? And there's a root. Where there's what? There's tap of the minerals and the water conductions from the root to the stem, and there's a conduction of food materials from the leaf to the part of the body. It makes sense, right? Just like this is the stem, right? I'm inserted into the ground, which is the root. Then I have plants where sunlight is being made, like converting inorganic materials like CO2, water, to give what? To give starch, C6H12O6 plus oxygen, right? In the presence of what? Sunlight and what? And chlorophyll. Chlorophyll. Very important, okay? Now that is why you must know that there are about what? 4 conditions necessary for photosynthesis. What are they? CO2 must be present, water must be present, sunlight must be present, then chlorophyll must be present. Alright, sorry. Chlorophyll must be present. So if you know that, we can go ahead. So that means this is from the leaf to the other part. Water will come from the ground to the other part, through the stem and the likes. So pay attention. You will never have to cram this part again. Now let's go. Now, if you see this and this should sound something to you, that this can never be roots. Why? There's no presence of what we call what? Root hairs. This is what we call what? Root hairs. Right? I mean, roots should have root hairs. So that is why if you see something like this, it shows that these 2 diagrams are roots. But you don't know which roots. Don't worry, I will tell you the roots. Okay? Now, automatically this diagram will be for what? Will be for stem. Of course, there's nothing like root hairs. That means this is also roots, but you don't know which roots. This is also roots, you don't know which roots, so I'll be teaching you how to know which roots. Now, since we already identified that fact, that these are stem, and these are roots because of the presence of what? Root hairs. Root hairs, okay? Now, let's go. Now, look at this stem, for instance. It is well coordinated, right? The stem is well coordinated. And don't forget that dicot is more advanced than monocot. Okay? That's why another thing you want to know is that the differences between monocot and dicot. Now, one of the differences that you want to know is that monocot or dicot, just like the name, they have 2 seed leaves, right? That's why they call them dicot. Why monocot have what we call 1 seed leaves? Okay? This part is very, very important. So, another thing you want to know about monocot and dicot is that dicot have what we call 4 to 5 floral parts, right? While monocot has about 3 floral parts. That's where it's just showing that dicot is still more advanced. Another thing I want to note is that for dicot, there is what we call what? Net venation. There's something like this, net venation. That is the leaves are in form of networks. While for monocot, because it is less advanced, you see that there is what we call what? Parallel venation. Okay? Parallel venation like this. You understand? So that is one thing you want to take note of, because this is dicot, this is monocot. Okay? Now, the major thing is now where we are. There is a particular part of dicot stem and monocot stem. There is a particular part of dicot roots and monocot roots. But another thing I want to know is that dicot has what we call what? Secondary thickening. Like cambium is responsible for the secondary thickening. They call it secondary thickening for meristematic cambium. Is dicot that has it, which can also divide to formation of xylem and phloem. Follow me through. Right. Now, how will you know that this is stem, dicot stem, or dicot or monocot stem? You want to know that. You already established that these are stem, these are roots, because root hairs is not here. Now look at this guy. If you look at this guy very well, you look at the stem here is well organized. Is well organized. Is well organized. Why this one has what we call what? Scattered stem. You know this, of course, when we talk about stem and phloem, right? This we are talking about vascular tissues, right? That's why we call them complex supporting tissues. Complex supporting, because I will talk about plant supporting tissues. Okay. Now, look at it. It is regularly organized. Look at this guy. It is scattered. The stuff is scattered. The vascular bundles here, the vascular tissue here is scattered. Of course, you should agree with me that should happen, because it is not what? It is not as advanced as dicot. So because this one is well organized, we say this is what? A dicot stem. Follow me. Why? Because this one is scattered. Can you see? It's scattered. Of course, it will have a pit, right? Dicot stem, we have a pit. But monocot roots, we have a pit. Don't worry, don't cram me. Just follow me. Now look at it. It is disorganized. Now that means this guy that you are seeing here, right? It is what? It is monocot stem. Right? Now what is that the vascular tissue we are talking about? There are two. Look at this. There's a particular part here. There's a particular part here. Now please note, xylem is always towards the center. Because in Jamb, they will just label this Roman figure 1, Roman figure 2, Roman figure 3. That's what Jamb will tell you to label. But people miss it. Look at it. For dicot, not dicot, it's not about dicot or monocot now. For everything, you must know that xylem is always towards the center. Right? Because you want to conduct ions like salt and water. So take note of that. So because dicot is always towards the center, that means, because xylem is always towards the center, that means this part you are seeing inside here is what? Is xylem. This part you are seeing outside, this shaded part you are seeing outside, is the what? Is the phloem. Please take note of what I'm teaching you because of exam. Now, in between the xylem and phloem is what we call what? The secondary thickening. So which comprises what we call what? This part here is the cambium. Is the what? Is the cambium. Responsible for what? Secondary meristematic thickening. Okay? So that is that. Now, that means we already established another fact. We already said this is stem and stem. Because you can see it is regular, it is organized. So this is what? A dicot stem. Why this one is a what? Is a what? Is a monocot stem. Good. Right? Now, what are the parts that you want to take note of? Very easy. They will ask you, what is this part called? The inside, xylem. What is the outside called? Phloem. The middle here is what? Cambium. Okay? Now, other thing that you want to take note of is what called the pericycle. This part that surrounds this, what you are seeing here, is the what? Is the pericycle. Okay? Take note of that. It's the pericycle. Now, are you following through? Good. Now, look at this guy and this guy. You already know that this will be roots. This will be roots, right? But you don't know which roots. That is why I'm here. Now, you can see that there is one called a star. A star inside. Can you see star inside? Now, if you are advanced, you become a star. That means the advanced, which is, of course, dicot, 2 seed leaves. Monocot, 1 seed leaf. That means dicot will be more advanced than monocot. Because you are advanced. So we say, for you to be advanced, you are a star. So the one that has star for the root, right? The one that has star for the, in fact, it's always easy to know which one is root or stem because you see root hairs which originate from the epidermis or the piniferous layer. Piniferous layer. Or the what? The epidermis. Okay, of course, epidermis covering, so epidermis. Now, because this guy has a star, dicot has a star, so this is dicot root. Automatically, this one will be what? It will be what? The monocot root. Why? Root will have root S, but this one does not have a star. So it just has what we call a large pit. This thing you are seeing here is a large what? Is a large pit, which will be present in what? In dicot stem, because it has a regularized vascular bundles. Of course, stem we have vascular bundles more prominent because that's what we are talking about. For vascular bundles, there must be at the center. Stem You understand? This is my stem. So conductions. So the one that must be inside, right? You are seeing this. The one that must be inside must be xylem. The one that must be outside must be what? Must be phloem. So that's why this is like this. Now, this star you are seeing here, star, X is also star. So because you are seeing this star here, is the xylem. This is our teaching, very, very important. Now, this part you are seeing here, is the what? Is the phloem. Is the what? Is the phloem. Okay? Follow me through. Is the what? Is the phloem. Because I'm going to teach you all these things. You don't have to cram it. Is the what? Is the phloem. Okay? Now, so if I ask which part is this? This is called the what? The root S. Good. Now for here, this thing you are seeing here, for monocot roots, this part is the what? Is the xylem. Right? Why this part you are seeing, this part beside this is the what? Is the phloem. Of course, I don't know why people miss this. pH. P means like photo, pH, photosynthesis. So for that is why for food translocation or food transport is the pH, xylem. Okay, pH, photo, food translocation. Why xylem is for water and mineral conduction. Okay, so don't miss that. And mineral conduction. All right, very good. So now look at what you're seeing. That means there can be what we call the epidermis. So this part here, where this air originates from, is called the what? It's called the epidermis or epidermis, depending on how you want to call it. Now this part you are seeing here is called what? It's called the cortex. It's called what? It's called the cortex. Now this, just like the same thing that you're having here. Now this part you are seeing, you see, this part here is called the endodermis. Endodermis. See, you can, that means, let me now use what I taught you, use it here. Look at it. The inside, the one that is inside, is what? Who can tell me? Because it's inside, it will be xylem. The one that is outside, it will be what? It will be phloem. Very easy way to know it. So now you can see that this has large pit, which is what? Monocot roots. This has large pit, which is what? Dicot stem. So just very easy thing. Very easy, right? I'm just trying to break it down and see. So let's go over it again. Then we'll now use it to answer that questions, okay? These are questions from Jamb. So I just want to explain, then you now use it to answer questions. So let's go over it again. So that you see that it is not hard. Look at it though. If you go to your Jamb pack, you will see all these questions I'm telling you now. So look at it. You have something like this. You have something like this. Then you have this. Then you have this. Right? Now, there is no root air. Abi? So the first thing I want to come to mind is that this is stem. Right? Because there's no root airs. The second thing I want to come to your mind is that, is this bundle, vascular bundle, is it regularly organized or is it scattered? Is it regularly organized or is it scattered? Okay? If it is scattered like this, of course, you know that this will also be stem because there's no root hairs. So this is stem, but you don't know which stem. I mean, this is stem, but you don't know which stem. So because this guy is regularly organized, so this one is a dicot stem. Because this one is scattered, I mean, monocot, they are not as advanced as dicot. So because this one is a what? Is a monocot stem. Very easy. The one that is closer to the center, right, is the xylem. The one that is outside is the phloem. Very easy. This bound ring that is inside here is the pericycle, okay? Pericycle. Very easy, no pressure, okay? Very easy. Now, I'm done with stem. Let's go to roots. Now, if you have roots, now the first thing I want to come to your mind is that roots must have what we call what? Root hairs. Okay? Root hairs. They must have what we call what? Root hairs. They must have what we call what? Root hairs. Now, the next thing is that you can have what we call what? A star. can have what we call a star. You understand? Then we can have this inside this, like, right? Now, because it has a star, of course, it will be dicot, because dicot, but rod, because it has root head, it will be dicot root. Now, this one does not have a star. It just has one. It just has this. It does not have a star. Look at this. Then it has this inside. Okay. Now, how should I not confuse this with this? Is that there's no root hair in stem. Why there's root hair in what? In root. For what? For monocot. Now, this guy is the xylem. Beside it is the phloem. Okay. And it has large pit. So I know, first of all, I know that this is root. Now, if I know that this is root, I cannot say it's going to be dicot root, because I know that for dicot root, there's what? There is a star inside. Why this one? Because I know that it is a stem, and stem has vascular bundles that are well organized. Okay? That's why I know that this will be what? Monocot roots. Very easy. So this is root hairs, this is the epidermis, the piriforous layer, this is the cortex. You understand? Then this is the xylem, this is the phloem. Okay? Very easy and very linear. Okay? No pressure. Now, before I go to supporting tissues in plant, or let me just go there, then we'll now answer that question, then I will now explain cross section of a leaf. Okay? Now, let's go. So I've done a breakdown of everything again. So now for supporting tissues in plants, there are three main supporting tissues. Sorry, there are two classes of the supporting tissue. The first one is that you can have simple tissues. Now, what are the simple tissues? There are basically three simple tissues. We have the turgid parenchyma. We have the parenchyma. I will not dwell on it here. We have the parenchyma, parenchyma, and we have the sclerenchyma. Okay, these are the simple. Now the complex tissues. These are supporting tissues. I mean, the mechanical support. They are basically two: the xylem, one, and the two. We have the phloem. Of course, you should know that these guys are also responsible for what we call the vascular support, the transport. Okay, water and minerals, food transport. So that's why these guys. That's why phloem is not majorly in mechanical support. It's the xylem that still contributes to mechanical support, and I will tell you why. Because xylem has 4 cells. Okay, the tracheids, the vessels, the fibers, and the parenchyma. So now, how do we differentiate this one from this? We call this one the xylem parenchyma. Okay, the xylem fibers. And don't forget that this xylem contain what we call the dead cells. The dead cells. So they are lignified. They are lignified. I don't want to go into the advanced where we're talking about the elongated cells. Okay, they are lignified. You understand? So these are the tracheids, the vessels, the fibers, and the parenchyma. Okay, these are the cells of the xylem. These are the what? The cells of the xylem. Yes. This guy also has 2 cells. The companion cells and what we call the sieve tubes. I mean, why do you not have a sieve tubes? You that want to transport what we call the food. So this has the companion cells and the sieve tubes. So this guy can contribute to mechanical support. Why? It has this lignified. All of them are lignified. But look at this. It has parenchyma. The xylem parenchyma. All right. So this turgid parenchyma is a living cell. Parenchyma is also a living cell, but sclerenchyma is also a dead cell. Dead cell. Okay, because it contains the sclerids and the fibers. This guy contains 2 cells. Yes, sir. The sclerid from sclerenchyma, and it also contains fibers. Okay, which are dead cells. You understand? So take note of that. This guy, this is living. This is also living. Okay, so these are the major 1, 2, 3, 4, 5. These are the major supporting tissues. But the major ones actually they are this, because this guy does not really go into support. It just helps in conduction, because it can see sieve tubes and companion cells. All right. So these are that. And now let's go to the question. So this, I believe we should be able to answer every question that will come out on dicot stem and monocot stem. Okay, I've told you difference between dicot and monocot. I've explained that. Okay, now look at the root hair is developed from dash. Where is this root hair coming from? This root hair is developing from the epidermis, or what we call the piniferous layer. I've already explained it. This root hair is developing from the piniferous layer, or what? The epidermis. Very easy. Okay, now number 2, identify the xylem, identify the phloem. Okay, that's 10 and 11. Okay, xylem. Oh yeah, we've done that. What is the xylem here? This is xylem. The inner is the xylem, the outer is the phloem. Identify the xylem here. The inner is the xylem, the outer is the phloem. I already told you why xylem was the inner. It helps in conduction of water and minerals from the what? From the root to the body. Why phloem? Because of food. Where does food happen? From the leaf to the other part. Good. Xylem is the what? I mean star. Right? This is a dicot root because it has root hairs. Where is the xylem here? This is xylem. This side here is the what? Is the phloem. Okay? Very easy. This is a question from Jamb. Okay. Now, which is responsible for minerals and water conduct? I've told you. Xylem. Very easy. That's where they ask you. It's a Jamb question. Okay? I brought out Jamb pack and I explained all of this. Now, which part is responsible for translation of food? I've already explained. Phloem, pH. Phloem for pH. So photosynthesis. Photosynthesis. Okay? Very easy. All right. What is the next one? Label the part of cross-section of a leaf. That is where we'll go to now. Okay? Cross-section of a leaf. Now, name which is dicot or monocot stem or roots. Because I want to finish this before I go to that. Now, of course, I already told you. How do you know monocot stem or dicot stem? For stem, it is vascular bundles that is the major thing because stem is for conductions. Right? What are the vascular bundles? The xylem and the phloem. Right? Now, how do you know it? For the xylem, for the dicot stem, it will have an organized vascular bundles. That's why this guy is organized. For monocot stem, it will have a scattered vascular bundles. Very easy. Now, how do you understand roots? Roots, the first thing is that it must have root hairs. How do you now know if it is stem, if it is dicot root or monocot root? For dicot, because dicot is more advanced, it will have what we call what? A star. So you call it a star. So this star, because I mean if you are advanced, you are a star. So that's why it must have a star xylem. Why does it not have a star? And it just have a large pit. So don't go and mistake. You can be thinking that why is this guy not the same as them? It's different. There's no root hair, so that's why this one is a stem, but a dicot stem. But there's root hair, that's why this one is a monocot root. Okay, very easy. We've been able to identify difference between monocot and dicot. I already explained that. Monocot and dicot. So for dicot, that's why dicot. Cot means cotyledons, 2 seed leaves. Monocot, mono, 1 seed leaves. Another difference is that for dicot, they have what we call what? Net venation. I already explained. It is like a network. While for monocot, they have what? Parallel venation. Okay, for like beans leaf, for instance, beans leaf, that's the shape. Okay, while for maize, monocot, M for M, that's that parallel venation. Okay. Another difference is that for root, I was saying that we left 2 parts, the stem and the root. For stem, for dicot stem, oh yeah, what is it? They have what? Regular, organized what? Roots. Stem, sorry. You can see vascular bundles are regular. Do you understand? While for monocot stem, they have scattered vascular bundles. For dicot, they have what we call a taproot system. Why? Monocot has what? A fibrous root system. Very easy. All right. What do you want to know? Roots. We are done with stem. Right? Let's go to roots. Now, for roots, what do you observe about the roots? We already said it. Taproots and what? Fibrous roots. Very easy. So what again? Secondary thickening for meristematic cambium is only present in what? In dicot. I already said it. Secondary thickening for meristematic cambium is only present in dicot. Take note of that. So now let's go to leaf, cross section of a leaf. Okay. Now, don't forget all these too. So these are Jamb questions. In fact, we've done about a lot of Jamb questions with this. I just want to make it to be 9 to 20. Okay. Now let's go. Let's go to leaf. Okay. So let me ask you a question. Is xylem a living tissue or dead tissue? Answer. Is xylem living or dead? Living or dead? And I only tissue. Is it a living or dead tissue? That's the first question. Yes, answer that. I already told you the 4 cells that it comprises of. Abi? The vessels, the fibers, the tracheids, and the parenchyma. Okay, the parenchyma. So if you want to also know it, you know the tracheids, the vessel, the fiber, and the parenchyma. Abi? I already told you. So I think the way I knew these things then is that the very fine parent. Do you know why I use parent? Parenchyma. So the very fine parent. Tracheids, vessels, fibers, parenchyma. So these are xylem cells. Okay? These are xylem cells. So the very fine parent. The very fine parent. That's why they can support and give you water. Xylem, support and water. So that's by the way. So let's go to this part. See, this stuff is very easy, but most people don't know it. It's very easy, okay? Now, if you have leaf and you do a cross-sectional area for leaf, what are the things you will see? I think you can screenshot so that I can go to this part. Because this leaf is so important in my life. Because most people don't know it. So I want to explain it very well. Now, when you have a leaf, they are part of leaf. Now, leaf in the sense that when we do a cross-sectional area, this is what you see. But most people don't know it. Now, there is this part that you are seeing. Before that part is this part. So this first part you are seeing here is called what? The cuticle. Okay? It's called what? The cuticle. That lining on top is called what? The cuticle. Now, this part here is an epidermis, but it's called, because it's on the upper part, it's called the what? The upper epidermis. Epidermis. Okay, very good. Now, we are moving closer. Now, look at this. That means if you are done with epidermis, you should be thinking of mesoderm, but we call them mesophiles. Mesophiles. But people don't know because there are 2 types. There is palisade mesophile and there's what we call spongy mesophile. So how do you know it? Palisade, packed together. Spongy, scattered, right? Sponge, scattered. So if they are, you can see that the way these guys are together, they look like pali. So this guy you are seeing here is the what? Is the palisade mesophile. So don't miss all these things. Why? You can see this. In fact, these guys are what we call what? The air space. So these are the air space. So that means if I ask you this part that is scattered is called what? What will you say? It is called what? It's called the spongy mesophile. Very easy. Spongy mesophile, right? Now, that means the whole of this from palisade and spongy, they are all mesophile. But pali is because they are packed. Now look at this thing you are seeing, this vacuum you are seeing here. This is the vacuum. Why this thing you are seeing, this organism with the vacuum is what? Is the chloroplast. Of course, chloroplast, which will contain the what? The chlorophyll. No pressure. So now this part, I already told you that time, don't also miss it here. That xylem is always towards the center. That means this first part you are seeing here is the xylem. While the second part you are seeing here is the phloem. Very easy. Now look at it. Look at this part also. It resembles this guy. So this guy will create is what? It is the lower epidermis. It is the lower epidermis. Right? But I want to take note of something. That means there will be what? There will be cuticle too. Right? The cuticle, and so it will be there. But this part here, you must know it. It's called the stoma. This opening is called what? Stoma. Singular is stoma. Plural is stomata. But there must be something that must guide it. That must guide the opening. I mean now, you can't just open. So there must be something that must guide it based on turgidity and the likes. So this guy has something guiding it. So this thing that is guiding it by this side is called what? It's called the guard cells. Guard cells. Okay? So that that. So that is why we name the part of cross section of a leaf. We have done justice to that. So these are the palisade, this is upper epidermis, this is cuticle, this is spongy, this is the xylem and phloem. These are the conducting vascular bundles, right? The xylem is towards the center, phloem is outside, right? In fact, you should also know that it shows that this stomach for water, when water enters and CO2, so phloem, transport from phloem, you can see how they conduct, and they are towards the center so that they can go through what? The pathway, from the phloem to other part of the plant. Very easy thing, okay? In fact, we've answered a lot of questions from this, and that's why I dedicated this part to answer question 9 to 20. In fact, I've answered a lot of questions from this part I just explained, and I hope that you can all answer any question on what? On monocot, dicot, stem or root and leaf. Okay, this part is dedicated for that. So I hope you understand everything I've explained so far. So don't miss it. It's very easy. And yes, so question 21. The ovule matures into dash. I mean, this is a common question that you must know, regardless of anything. You must understand that the ovule of a flowering plant develops into what? Into seed. Develops into seed, okay? It develops into seed. While the ovary matures or develops into dash, you must know that this one develops into what? Into fruit. Okay? These are no-brainer. You must just know it. Okay? So the ovule matures into seed. The ovary matures into fruit. Okay? That is how that happens. Okay? Maybe in another video I'll be talking about, if you want me to also drop it, maybe I should talk about flower. I should use a video to dedicate on flowering plants, where I will talk about the gymnosperm and all those things. Okay? If you want me to talk about it, let me know in the comment section, okay? The most abundant group of animal group is dash. The most abundant group of animals, I think there should not be group here. The most abundant group of animals is dash. You must just know that insecta, that is the class insecta, is what? Is 70% of animal kingdom. The plant insecta is 70% of animal kingdom. You must just know. In fact, you can check around this video where I talk about the classification of living organisms, okay? Where I explain from where? From the monerans to protista, to fungi, to plantae, and what? And animalia. Okay, we are explaining these are the major 5 kingdoms that we have. These are prokaryotic, right? The first nucleus organism. The prokaryotic, where we have the bacteria and the cyanobacteria or blue-green algae. The protista, where the amoeba belongs. The fungi, where we have mushroom, yeast, mold, and all of that. Plantae, where we also talk about that this plantae can also go into divisions. I don't know if you have seen that video. Okay, I explained all of those things here. The 3 divisions, the Talophyta, the Bryophyta. You have not seen it, it's around this video, and the Tracheophyta. Okay, where I gave you an example of the Talophyta. Okay, the Spirogyra and the Volvox. Okay, then I gave you the example of Bryophyte, the liverwort and the mosses. Okay, have you seen that video? You should have seen it. So I also went ahead to explain Tracheophyta, right, where I divided them. Have you seen that video? You should have seen it. So where we have the seed plant and the flowering plant. Do you get? I don't know if you have seen it. So you go and check it. Where I explain a lot of things there. The fence, the pteridophyta. Okay, where I explain. This Tracheomys vascular plant. Okay, the pteridophyta. I move ahead to explain flowering plant, the angiosperm, gymnosperm. Okay, from the angiosperm and gymnosperm, I move ahead that angiosperm can also be divided. Understand? Where I go ahead to talk about the monocot and dicot. Where I say dicot is the most advanced. You should check it out. Okay. Then the animals too. I move ahead. I also explain part of them, the invertebrate and vertebrate. Understand? The para. Okay. You must know that para. The para. I'm just trying to revise already in case you have not seen it. The para, the Pisces, the amphibians, the reptiles, the apes, and the mammals. Okay. Then I also explain the mammals. I also talk about a lot of things. You can check it out on this video, right? If you are watching this on YouTube, you can check it out. Okay. All right. So that this will not be long. So the most abundant group of animals is the insecta. Okay, insecta. Please take note of that. They are generally under the phylum Arthropoda. Okay, so the Arthropoda is now divided into different classes. You know, the crustaceans, the insecta, the myriapids. Okay, I don't know if you have seen those things. And arachnida, the siam, the Arthropoda. Arthropoda is divided into 4. The way I know it since then is siam. Siam. What does siam means? Crustaceans, insecta, arachnida, and myriapoda. You understand? You should have seen something like the centipede and the millipede. I'm just giving you rough because I've explained some things around that. That's why I'm not dwelling more on that. So watch the video around it. But the answer to this question is what? Insecta. Okay? It contains 70% of animals. Now, dental formula of man. I mean, you must know this because you're a man. Okay, what is dental formula? Now, when I say man, I mean male and female in biology. Okay? Take note of that. So, the dental formula of this. Now, what does dental formula mean? Dental formula is the number in the half part of the jaw of the teeth. You understand? Half, that is when you divide these teeth into 2. So the number of teeth in this half, like this, is the what? Is the dental formula, not the total teeth. You must know that mammals or man now, we have 32 teeth. I mean adults, grown secondary teeth. While the child, the child basically had what 20 milk teeth, 20. While we have 32. All right. So you must know the types of teeth that we have. We have the incisor, the canine, premolar, and molar. Okay, now the way I used to know these things from secondary school and the way I'm going to teach you is that for, we are talking about half teeth. That means you should expect that this formula should give me how many set of teeth? 16. Like 16 different teeth, right? Because I'm talking about half jaw. If you have 32 altogether, this one should give me what? It should give me what? It should give me 16. Okay, and also you should know that rabbits, they have how many set of teeth? If it is dental formula, it will be 14. If it's the whole teeth, they will have 28. The carnivores, they have what? They have 42. But if it is the dental formula, it will be 21. So it is 21 times 2. That's how I used to see it. So I'll use mouth to explain that. So the way I used to know it is that you just say 2. 2, do you get it? You say 2. Then you now say 1, 2, 3. Open your teeth. 2, 1, 2, 3. Look at what I said. That means you say 2, upper jaw, 1, 2, 3. That is all. So the same thing will be down. 2, 1, 2, 3. So that is why this one is easy. So just say, open your teeth. The incisor, the first set of teeth you will see. The first 2 sets of teeth are the incisors. The third set is the canine. The next set is the premolar. And the next is the what? Is the molar. They are the 3 sets. So you can see. So if you add 2 plus 1 plus 2 plus 3. 2 plus 1 is what? 3. 3 plus 2, 5. 5 plus 3, 8. So 8 times 2. That's why this is what? 16. So you have 16 teeth in the dental formula. What do you mean? Like, because it is what is represented in the what? In the half jaw. Half. So it's when you now times this by 2 that you now have the 32 teeth that we have. Do you understand? So if I ask you what is the dental formula, or the dental formula for instance, let's say herbivores, like rats, you understand? It will be what? 14. But that's what are the 10th of teeth, it will be what? 28. Do you get the difference now? Good. So the answer to this is what? Incisor, canine, premolar, molar. So what do? 2, 2, 1, 2, 3. So same thing. So that's why it is easy, okay? The greatest amount of energy will be obtained from 100 kilograms of dash. Most people don't know. They think it's carbohydrate that gives the highest energy. No, it is fats and oil. So in the Jamb exam for this question, they put meat, they put bread, and but the answer they put that is correct is what? Is butter. Okay, fat and oil. In fact, for context, it gives about 32 times. It gives about 2 times that of carbohydrate in terms of energy. Fat and egg give about 2 times energy. It's about 32 kilogram per joule, while other ones give 16. Protein gives the same as carbohydrate, but fat and egg give times 2 of what carbohydrate will give, times of what protein will give. So it gives the highest amount of energy. Okay, take it from that. The element common to carbohydrates, lipids, and protein is that, of course, as regards this past question, the element that is common to all of them is what? Is hydrogen. Of course, you should know that carbohydrates, just like the name, carbohydrates, it means it contains carbon and hydrates. And when I mean hydrates, we are talking about what? Water. So that's why carbohydrates comprises of what? CH2O, bracket Y and X. Okay, CX, H2O. So you see carbon is there, hydrogen is there, oxygen is there. Yes, in protein, for instance, we have sulfur, we have nitrogen. So the most appropriate answer here is what? Hydrogen. According to the Jamb question here, so it's hydrogen. So I'll just explain that. Now, which of these elements is a trace element? Now, you must know this, and I will teach you how to know it. Now, if you talk about trace elements, there are basically 5 trace elements. And when I mean trace element, I mean micro elements. And there are basically 7 macro elements needed in large amounts. The macro. Okay? So, we'll go with the 5 trace elements. So what are the 5 trace elements? What are the 5 trace elements? You must know it. And the way I know it is what? M squared CBZ. M squared CBZ. What do I mean by M squared? The first M is what? Is molybdenum. Molybdenum. The second M is what? Is manganese. Now don't confuse this with magnesium, which is the what? Is a macro element. The next one is C. Now this is not calcium, this is what? This is copper. The next one is B, which is what? Boron. Then the next one is Z, which is what? Which is zinc. So these are the 5 trace elements needed in small quantity. So the answer to this question is what? Is copper. Is what? Is copper. Okay, now if I want to go to explain the 7 what? The seven what's it called? The 7 macro large one. You understand? So I use the mnemonics P squared mix. P squared mix. Okay? That is P squared then mix. You understand? It's not like the way they make music, okay? P squared mix. Okay? What does P mean? The first P is potassium. The second P is what? Is phosphorus. There are 7, no? There are 7 in number. The first M here, this M here is magnesium. You see, it's not, that's why I said it's not molybdenum or manganese. The I here is what? Is iron. And something is worthy of note here. Ni, these guys are the one responsible for what? Chlorophyll formation. Chlorophyll formation. Okay? They are the one. I'm sorry for the mic. The words. I don't have, if I'm not with my mic, I forgot my mic and my markers. Okay? I just got this. So you see the sacrifice. So comment, like, share this, subscribe to this channel. I mean, it's not easy. I have to do this video for people so you guys can learn the basics of things. It's not hard. It's easy. Okay? And yes, I wish you all the best in your Jamb exam. I wish you good success. I wish you that 300 plus. If you believe, type amen in the comment section. Okay? See you. Now, mix. N here is what? Is nitrogen. The C is what? Is calcium. Then the S here is what? Is sulfur. So these are the 7, 1, 2, 3, 4, 5, 6, 7. So these are 7 macro macro elements. Okay, if I made a video on this too, I made a video on this. Okay, macro elements, and it's for what? Chlorophyll. Mi is for what? Chlorophyll formation. Never forget that. So that is that. Now, so take note of that. So list the fat soluble vitamins. You must know it. You must know the fat soluble vitamins. So how do you know it? Very easy. Very easy. Fat soluble vitamins. So we use the word ADEK. 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 Vitamin A, vitamin D, vitamin E, and vitamin K. So ADEK are the fat soluble vitamins. Water soluble vitamins are what? Vitamin B and vitamin D. Now we now say vitamin B complex because it's not only one vitamin that we have. And vitamin what? C. So these are the water soluble, and these are the what? ADEK are the what? Fat soluble, okay? Fat soluble. Alright. Okay, just like we said, we have explained this and that. So I'll be going to, so B complex, you know, we have vitamin B1, vitamin B2, vitamin B3, you know, we have vitamin B5, vitamin B6, vitamin B9, and vitamin B12. So because there are a lot, so we call them B complex, okay? Now, let's go. Now, the question here is the fat, where is it? Okay, fat soluble, we already said ADEK, have we? ADEK, okay? We already said it, those are the fat soluble, vitamin A, D, E, and K. So, deficiency of vitamin dash leads to scurvy. See, don't ever miss this question. Scurvy, right? Now, the way I used to know this is that, I don't know if you guys have seen, you should have, maybe you might not have experienced that. The connective tissues in the teeth, you know, their presentation most of the times, you see it in their, you know, oral cavity, where their gum loosened, right, and their teeth are loosened because of the connective tissues are deficient of vitamin C. Vitamin C. So why do I know it? The word vitamin C, another name for vitamin C is actually ascorbic acid. Ascorbic acid. So I used to think that, oh, since it is scurvy, C, so it's deficiency of what? Vitamin C. Okay, so the other thing is deficiency of what? Vitamin C that leads to scurvy. You see them that, you know, they are, there's hyperemia, sorry, that's medical term. I forgot that I'm a medical student, so I don't want to use those terms for you. Redness of their gums, okay, and their teeth tend to loosen, you stand. So that's the difference. We can teach you what you need. When you now enter school, it's another thing. So we don't use the word. Hyperemia means redness, okay? Let us go there. So, deficiency of vitamin dash leads to rickets. Now, you should know that, you should know the difference between rickets and osteomalacia. Okay? If it is rickets happens in, what's it called? Children. Okay? Why osteomalacia happens in adults? You understand? So, where their bones, the formation of the bones is softening, you understand? And leads to bow leg, you understand, and the likes. So, it's the deficiency of vitamin D. You should know about this vitamin D very well because, you know, most of the time they say when you go to early morning sun and all of that, you know, it gives you vitamin D. No, it doesn't. It's not like it gives you vitamin D. It activates formation of vitamin D from the skin and the lights. Okay, that's what happens in that case. So vitamin D, you understand, calciferol, you understand. So it leads to deficiency of vitamin D leads to what? Rickets or osteomalacia. And there's a process of this, you know, calcium metabolism. But I don't want to go into that. Just know that the level of vitamin D leads to rickets in child and osteomalacia in adults. Please take note of that. This one happens in child. This one happens in what? In adults. That's the difference. Okay? Now, dash. Which element is responsible for hemoglobin formation? I mean, you should know that hemoglobin, when we draw the structure of hemoglobin, iron is present. So, the element responsible for that is what? Is iron. Okay? Iron is responsible for that. Okay? So, which element is responsible for hemoglobin formation is iron. I don't know which one is responsible for what? For chlorophyll formation is magnesium and what? And iron. Mg. So in case most of the time they will not give you the two options, but in case you see the two options, you can still towards iron than magnesium, okay? But they will not give you the two options when they are not wicked. So this was 31, then we'll go to the last set of questions. 32. Alright, so starch pounds the iodine paper dash. Alright, one of the things that you want to understand about starch is that we have to test for starch, right? And we want to know if starch is really formed. And one of the things that you have to realize is that the conditions, the things CO2, I've said this, H2O, sunlight, and chlorophyll. So we can test these guys by testing for starch. Alright, we can test their effects, if they are present or not, by testing for starch. So if let's say we absorb CO2, right, that means starch will not be formed. If we remove water, that means starch will not be formed. If you have it taking place in a dark environment, dark room, in a cupboard, starch will not be formed. Chlorophyll is deficient of chlorophyll, starch will not be formed. Right? You would have seen where we talk about variegated leaf, where some yellowing part happens because of chlorophyll deficiency. So this must be present. These are the 4 conditions necessary for starch. So this was very before before this can form C6, H12, O6, the release of what? Oxygen. Okay? Now, the first one is starch turns. I've made a video on that. You can go check it. Alright, we've ended our marathon class. If you want to get the marathon recordings, you are listening to this on YouTube or anywhere, just check around. You see my number, send me a WhatsApp message to get the recordings, okay? We've ended the marathon class, a 7-day intensive marathon class where we discussed extensively on a lot of things, chemistry, So, starch turns dash iodine paper dash. Understand? So, when we have iodine paper, where we have to test for starch. Okay. Now the thing, there are 2 colors you can see. Sometimes they will say dark blue color, or sometimes they can say blue black. Okay, either of the 2 is correct. Okay, so you see that coloration changes to a dark blue, understand, or blue black. Either of the 2 is correct. So I'll just go with maybe dark blue. Of course, you cannot see the 2 in the option. So dark blue, because that's iodine paper dash. So that shows that starch is present. If this does not happen, starch is absent. Okay. Now, the food substance which produces red coloration with soda 3 solution, you must know this one, is fat and oil. Fat and oil. It produces red coloration with soda 3. Another very important test about fat and oil, which you can try it at home, is translucent. It's a translucent test. If you put a starch paper on a white paper and you look through it, you will not see through it, but light can pass through it. Okay, it's translucent. You can test it, you can do it right now. So promise me you are going to do it. Tell me in the comments, I will do it. So I will know that you will do it. So go to your kitchen, go and bring that oil, put it on a paper and check through it. Instant. You see that translucency, which tests for what? Fat and oil. You see that these things are something you can even test now. So, alright, that is that. Then number 34. The added substance in the body. This, I'm going to explain this in 2 ways. Added substance. Look at it. The tooth, for instance, singular tooth, plural teeth. If you have it in such a way that we have this, okay, now we have this. Now, this part, this outer part here, covering the inner part here, is called the enamel. Okay? Now, this inner here is called the dentin. I'm going somewhere. Now, there is a part covering the dentin at this side, which is called what? The cementum. Now, you might not need this one. There are some ligaments here. Holding it to the alveolar bone. Okay, this is the alveolar bone. So these ligaments are called periodontal ligaments. Okay. Now these are your gums, the gingiva, the gums. This one, the outer part here is the gum. All right. Now, the added substance is the enamel. But the hardest living, I repeat, the hardest living substance in the human body is the dentin. Now they ask you, what is the largest organ of the body? Is the what? Is the skin. But then when they say, what's the largest organ in the body? Is the liver. You understand? But most of the times, skin, if you see the 2, you choose the skin. You understand? The coverings, okay? All right, so that is that. So please, if it is living, hardest living substance, you choose the 18. If it is hardest non-living or substance, is enamel. If I ask you, okay, good. The living part of the teeth, this part here, is the what? Is the pulp cavity. Pulp cavity. Pulp cavity is the living part of the tooth, okay? Pulp cavity is the living part of the tooth. Alright, that answers that. So the answer to this question is what? Is enamel. That is the hardest non-living part of the body. Take note of that. So the functional unit of the kidney, I mean, everybody should know this. It's about 1.2 to 1.5 million nephron. Nephron is the functional unit. Just like when you say the functional unit of the liver is the hepatocyte, you know, we can talk about the functional unit of a lot of things. Okay, a lot of things. So for the kidney, you know, we have two kidneys, right? It's a pair. So the nephron is the hardest part of, is the functional unit of the kidney. I wanted to draw it for you guys, but you should also know it because they can ask you different parts of the nephron. Okay. Okay, so now we can have the glomerular filtrate, right? See, this is the Bowman capsule. The Bowman capsule, this is like a bowl, right? These are the glomerulus, right? The filtrate happens. Then the proximal convoluted tube, right? This is the what? The loop of Ellens, okay? Then this is the distal convoluted tube. Why this is the what? The collecting duct, okay? The collecting duct. So this is the atypical part, it's a typical nephron. Alright, this is a typical nephron, which is the functional unit of kidney, okay? Just take note of that. Alright, so that answers that. They are about 1.2 to 1.5 million. So when a person with blood group O lost blood due to an accident, he can be given blood from dash. Now this, I must use this way. Right, now look at this. You must know that, first of all, you must know that when we talk about donation, you know, there must be a receiver, there must be a donor, right? Imagine now this guy has, with a blood group O, it has a blood group O. That means it's the one I want to receive, right? Good. So now, first of all, you must know that universal donor is blood group O. While universal recipient is what? AB. So we'll be talking about the ABO system. ABO system. Now when I mean ABO system, I'm talking about ABO because we have two systems. We have the ABO system blood grouping and we have the rhesus factor system. So for the ABO, now we have blood group A, blood group B, blood group AB, and blood group O. Right? For the ABO system, blood group A, blood group B, blood group AB, and blood group what? O. Now, for blood group A, now that means, first of all, since universal donor is O, that means all these guys you are seeing here, all of them, they can receive blood, right, from blood group O. All of them, they can receive blood from where? Blood group O. Because blood group O is a universal donor. That means blood group O can donate to A, blood group O can donate to B, blood group O can donate to AB, blood group O can donate to what? O itself. Do you understand? So, because blood group O is a universal donor. So, let's give a chart. Right? These guys are the recipients. So, in terms of donor, so we already said this guy can receive from O and A. I mean, is A, right? So, which means I can receive from A. Do you get? So, this guy, recipient A, this guy that wants to receive, he can receive from O and A. Do you get? Because O is a universal donor. B can receive from O and what? and B. That is, if the person that has accident is blood group B, it can receive from O, because O is a universal donor, right? And B itself, it cannot receive from where? It cannot receive from A. In fact, it cannot receive from AB. But AB can receive from all of them. That is where you have now. You are not at AB. Universal recipient, right? That means for you to be universal recipient, you can receive from A, you can receive from B, you can receive from AB, you can receive from O. So you see, so if you now get here, you say, AB can receive from A, AB can receive from B, AB can receive from AB, and AB can receive from O, because it's a universal recipient. Now, blood group O as a recipient cannot receive from A, cannot receive from B, cannot receive from AB. It can only receive from O, because it can donate to all of them, but it cannot receive from all of them. The only one that can receive from all of them is AB. So that's why they call it AB. And there's a reason for that, actually. Now, blood group O, they are saying it has antibody A and antibody B. They call it agglutinin. The antibodies are called agglutinins. The antigens are called agglutinogens. So when the mixing happens, incompatible blood groups, there will be what? Agglutination. That is clumping of blood. Okay. Now you can see what I'm saying here. So now blood group O has what we call. You can also note that blood group O has what we call anti-A and anti-B. You understand? What do I mean? Antibody A and antibody B. Why can this one receive from all of them? It's because it has antigen A and antigen B. Okay, this guy has no antibody. This one has antibody A and antibody B. I'm using this to explain everything now. You need to know. So antibody A and B. Now, why is this guy only able to receive from O and A? And it cannot receive from B? It's because it has antigen A and it has antibody B. So anything that comes that resembles B, clump. That's what it means. Because it's antibody against the body. Antibody. So this guy we have antigen A and what? Antibody what? Antibody what? Antibody B. You understand? Antibody B. Do you get that? I'm trying to check something. Okay. Now B we have what? Antigen B. Anything that looks like B, I will accept. But anything that is not B, I will enjoy it. So that's why it will have what? Antibody A. So these questions can come in different ways. So now the other 6 question. Look at it. A person with blood group O, right, lost blood due to accident. He can be given blood from what? The only person that can donate, look at the donor, is what? O. It's only O that can give him blood, not B, not AB. Do you get? But if the person, so the answer to this question actually is what? Blood group O. But let's say the person is AB. In fact, that's why those people they can live long if they have any issues as regards blood. Because they are universal recipients. A, come, I will collect. B, you can come, I will collect. O, you can come, I will collect. AB, you can come, I will collect. If the person is blood group A, it can only receive from A and O because O is universal. If the person is blood group B, it can only receive from B and O because O is universal. If the person is blood group O, another problem, it can only receive from what? Blood group what? O. That's why it is very hard when you have blood group O, because don't go and exercise anything that is involved with blood loss, because you can see what happens. Only O that can give O. So take note of that. Hope you understand. So I will start to explain that. The stages of complete metamorphosis is dash. The way I know these stages is I use the word helper. Helper. What does helper mean? From egg to larva to pupa to adult. That's where these are the stages of what? Complete metamorphosis. Complete metamorphosis. Helper. But if it is incomplete, I use the word who is any. If you are any, tell me that you are any. So I use the word any for incomplete. What does it mean? Any in the sense that egg will go to nymph. Nymph. Therefore, nymph to what? Imago. Or what we call, let us have. Yeah, thank you. Yeah. So, okay, so for any, right? Now, any in the sense that from egg to nymph to what? To imago. So this imago, another name for this imago is the adult. Okay, another name for imago is the what? Is the adult. So helper for complete metamorphosis, complete. Then imago is for what? Incomplete metamorphosis. Sorry, any is for incomplete. Egg to nymph to imago. Okay, that's answer. So the stages are what? Helper. Don't forget. Helper, egg, larva, pupa, and adult. Okay. All right. The gymnosperms are referred to that. You know, when we talk about the flowering plant, they are divided into two: the gymnosperm and angiosperm. Okay, the gymnosperm and angiosperm. Those ones that bear their fruit on a cone, right? On a cone, they bear their seed. Sorry, on a cone, they are called what? Gymnosperm. All right, they are bear, so, and that is why they call them. We call them what? Because they bear their seeds on a cone. We call them conifers. Conifers. Cone. Conifers. Okay? So gymnosperms are referred to as what? Conifers. You can press this on your Google, you will see it. So they resemble like that cone. Look at it. This is the way their stalk is. Can you see? This is the way a cone looks like now. If you draw it from here. So this is their shape. You can check it on the Google now. So what are the examples? So the way I used to know these things. So let me just finish this. The way I used to know these things is why I purposely gave you as Jara as question 41, so that you know it. Now there's RCCG, but this one is GCCG. So change the RCCG, Redeemed Christian Church of God. Okay, change it to GCCG. What does GCCG means? G means for gymnosperm. Gymnosperm. Okay, what are the examples? C, C, G. So the first G is that they call them conifers. Okay. The second one, another example is that this is an example. Conifers is an example, but we just name them as conifers. The other one is cycads. Yes, and the last one, G, is what? Is gingos. Gingos. So these are the examples. Okay. Why the angiosperm are divided into two? The what? The monocots and the dicots. Okay. And I already explained these things, so I have a video on it, so you can check around this part. Okay. So the example to these questions, just like we said, the conifers, the cycads, and what? And the gingos. And the gingos. These are the three examples. Okay. Common ones to some extent. So I hope you've learned a lot from this video, and I wish you all the best in your exams. This is still your exam period. I'm still making videos for you guys. So support me, subscribe to this channel. If I've helped you so far, comment I've helped you, and subscribe to this channel. Share this to your friends, share to your secondary school mates, help them too. I mean, some people are just lamenting that they just got to know my channel so a day to exam. So help them from now, share it to them. If they still have exam anytime, share it to your group. Even though they don't have exam, let them wait for post-TME. Okay, so share it to your group, subscribe, make sure you subscribe to this channel. And if you want to get the recordings of the marathon class, a lot of people register for that marathon class. So if you want to get the recording, send me a DM. Either I'm watching this on YouTube, send me a DM, check my number around this. I'm also put my number here, then you reach out to me and for the recordings. Okay, from this video, I will see you in my next video. Bye for now.